about set notation. So there's a lot of new symbols you're going to learn. You're going to learn what they means, and they're very easy to learn. And this is relevant for this topic. All right, okay. So set notation is a collection of objects. So what is a set? Is a collection of objects denoted by capital letters. The objects can be listed inside curly brackets. So these are a set of 5 numbers here, and we use curly brackets to embrace what's inside this set. So the set A has the object 1, 2, 3, 4, 1, 2, 3, 5, 7. So that's a set of numbers. Okay, we use pronumeral capital letters to denote this set. So for objects in a set is called elements. We say 5 is an element of A, means 5 is an element of A. So that symbol that looks like an E means element of. Okay? E. Okay? Is an element. Oh yeah, thank you. Is an element. No. Is an element of A. So in that case, C5 is inside the set A. So you can think of a set as like a bag of elements. So 5 is inside this bag. Okay? All right, next one, we got subset. What's a subset? A is a subset of B if all the elements in A are also contained in B. Okay, so A is a subset of B is everything in here can be found in B. So you can see 1 can be found, 2 can be found, 3 can be found, 5 can be found, and 7 can be found, right? So we say A is a subset of B. So the symbol is A subset of B. Okay? Yeah. Okay, let me just... Next symbol you're going to learn is called the empty set. So if a set has nothing in it, it's called the empty set. It's like 0. It's like 0.
If a set has 0.
Yeah, but that's a set. That doesn't represent number. Okay, empty set. Empty set. Okay, watching, continue on. NA means the cardinal number. What's a cardinal number? Is the number of elements in A. So how many elements in A? 1, 2, 3, 4, 5. So NA means 5 elements in A.
How do you write that?
N.
What, 5?
Because there are 5 elements. 1, 2, 3, 4, 5.
Oh, right.
Yeah. So this one, cardinal number, is the number of elements in that set. So the set A has 5 elements. 1, 2, 3, 5, 7. 5 numbers. So you write the number 5. MB, yeah. What's MB? MB will be 1, 2, there's 8 numbers, right? So you get...
Just like P bracket. Yeah. Just like P bracket.
P is the probability. Yeah, yeah. Okay, let's look at the next one. Yeah. C is upside down. That's an N. N. Number. N for number. N for number. And oh, C subset, it's not upside down, it's like this, subset, like this, right? Oh, this one? This one? Is it this one you look at? This means the intersection. No. Okay, that's the intersection. Watching. Intersection. Okay, now. Intersection of A and B, common elements in both sets. So for example, if you do A and B, what's common to A and B? Obviously the 1, 2, 3, 5, 7. This is common. Okay. So the common element A and B is 1, 2, 3, 5, 7. And if it's upside down, the other way looks like a U, that means the union. Means elements in either A or B. We'll do example of that.
So all of the numbers.
Yeah, all the numbers. And then A with the apostrophe called A prime is called the complement of A, contains the elements not in A. Okay? Contains elements not in A. All right, let's do some example. What's... Thank you. All right, example 1. A number is chosen from a set of positive numbers, integers between 1 and 8 inclusive. A is a set of odd numbers, 1 to 8 inclusive, and B is a set of prime numbers, 1 to 8 inclusive. List the sets, the sample space. The sample space is the numbers chosen from 1 to 8. So the whole set is 1, 2, 3, 4, 5, 6, 7, 8. Like that. And the set A is a set of odd numbers from 1 to 8. So that means you write 1, 3, 5, 7. These are the set of odd numbers. And then B is the set of prime numbers. Now, is 1 a prime? No, you only got one factor. So 2 is the smallest prime. 3, 5, 7. Right? These are the prime numbers. 8 is not prime. Inclusive as if you only consider numbers from 1 to 8 only. You consider 1 to 8. Otherwise, what's the point of saying prime numbers? You just write all the numbers. 1 to 8 means you only consider the prime numbers between 1 to 8. You don't have to include the first or the last number. Okay, let's draw a Venn diagram. So the Venn diagram will look like this. Sample space is all the possible numbers because you are selecting from 1 to 8. So it's all the numbers. All the possible. So when you do experiment of choosing numbers from 1 to 8, these are the possible outcomes in that experiment. Yes? Yes, Luca. Now you will. So put a rectangle. Yes, because there could be something outside the rectangle. Yeah, in this case, look, A is here, that's B. Now, what are the elements that's common? 3 is common, 5 is common, 7 is common. So you write 3. So there are 3 elements in here. And how many elements outside the Venn diagram? So there's 1 that's only in A, 1's only in B. How many that's not listed in A or B? 4. Not 4. The only thing that's not listed is 8. 3. Yeah. So you write down how many numbers in each.
8.
No, 1 element. You're writing how many elements? How many numbers? How many numbers? I think the rule is for Venn's diagram, you always write down the numbers of elements. Just like the one before, you write how many elements, right? So it can be a bit tricky. Try the element, list the set common to A and B. That's intersection. No, just the, 3, 5, 7. Only 3, 5, 7 are common. Okay. Curly bracket means it's inside a set. We're looking at the set. List the set for A or B, elements in A or elements in B. So what are the elements? Could be 1, 2, 3, 5, 7. So A or B means either in A or B. Not in A, this is not A, so which one are not in A? 2, 4, 6, 8. Basically the even numbers. Okay? And B only, just 2. Make sure you use curly brackets, a set. Yep, just 2 by itself. Okay, NA, how many in A? 4. What's the probability of A? Will be 4 out of 8, which is half. See the difference between NA and PA. PA means probability, NA means how many. And how many in A and B? 3, right? There's 3 numbers. And what's the probability of that? 3 out of 8. Get the idea? So it's very easy. You just have to get used to the notation. NA 4, because there's 4 in A. See? 1, 2, 3, 4. Not 4 only. Not 4 only. Or, yeah, okay? Get the idea? Thank you. It's how many